Hi, it's Justin Schubel. Today we're going to be doing free response question 4 from 2011. The continuous function f is defined on the interval -4 to 3. The graph of f consists of 2 quarter circles and 1 line segment, as shown in the figure above. Let g of x equal 2x plus the integral from 0 to x of f of t. So the first thing I would do when I see this problem is, up here I would say g equals antiderivative of f. G prime equals f, and g prime prime equals f prime. This is just very basic because then you have to go back and look at the fact that you do have that 2x, but I would still write this up here to remind us. A says find g of -3. Find g prime of x and evaluate g prime of -3. So, in order to find g of -3, we're just going to plug in -3 into our equation for g. So 2x would be -6 plus 0 to -3 of f of t. So we have -6, and we can flip this right here. Instead of having it go from 0 to -3, we can make it negative and then go from -3 to 0 so that it goes in order and makes it easier to find area. So then to find this value, what we're going to do is go up to our graph and we're going to find the area between -3 and 0. Sorry, it would be right here. And that value is 9 pi over 4. So our answer is -6 minus 9 pi over 4. Then, to find g prime, we just do the derivative of 2x, which would just be 2, and then we do the derivative of the antiderivative of f, which would just be f of x. So then, to find g prime of -3, we plug in -3 into this equation. And so we're going to have 2 plus f of -3, and if you look at our graph, f of -3 is 0. So 2 plus 0 equals 2. For b, we have to determine the x-coordinate of the point at which g has an absolute maximum on the interval -4 to 3. And then we have to justify our answer. So in this case, in order to find where we have an absolute maximum, we're going to need to test the endpoints, so -4 and 3, and then also we're going to need to test any place where g prime changes from positive to negative, meaning we can test g prime equals 0. So here, in order to find where g prime equals 0, you set g prime equal to 0. So here you have 0 equals 2 plus f of x, meaning f of x equals -2. And if you look at your graph, f of x equals -2 at x equals 2.5. So that's going to be one of the points we're going to need to check. Then we're going to check on our number line and see and make sure it goes from positive to negative, which it does. So that means it's a max. Now we need to check our endpoints, which are -4 and 3, and check 2.5, and plug those into f of x to see which one is our absolute maximum. If you look at our graph, you can see that our endpoints are not going to work because we're going up so much here, because the area is so positive, that we're not going to be able to recover all of that with our endpoints. So that's why you really only need to just use 2.5, because we know it's a max, and we know that we're not going to recover all of that area. So your answer is x equals 2.5. For C, we have to find all the points on the interval, all the values of x, where g has a point of inflection. So in order to find a point of inflection, we're going to see when g prime prime changes sign. So in this case, g prime prime equals f prime, like we said before. Sorry, I didn't mean to erase that. Since g prime prime equals f prime, we're really trying to find where the slope of f changes sign, meaning we can find where f prime equals 0. So if you look up at our graph, it cuts off, but we do have a point at x equals 0 where our slope changes from positive to negative. So this is going to be our point of inflection. Our slope doesn't change sign at any other points, so this is our only answer. Finally, for D, we have to find the average rate of change of f on the interval -4 to 3. And then we have to prove something. But first, let's find that average rate of change. So in order to do that, we just do slope. So we do y2 minus y1 over x2 minus x1. So in that case, we're going to have f of 3 minus f of -4 over 3 minus -4. So the 3 minus -4 is just going to give us a 7, and f of 3 is -3. As you can see on the graph, f of 3 is -3, and f of -4 is -1. So -3 minus -1 is -2, and -2 over 7 is our answer. So then they ask us, they say there's no point C on the interval for which f prime of C is equal to that average rate of change. Explain why this statement does not contradict the mean value theorem. Well, anytime we hear mean value theorem, we want to think, is it continuous and is it differentiable? In this case, our function is continuous on the interval. If you want to look up here, our function is continuous, but our function is not differentiable because you can't see it, but we have a corner at x equals 0. So the fact that it's not differentiable means we do not have to have this certain c that equals -2 over 7, whose slope equals -2 over 7. So therefore, you could say the function must be continuous and differentiable for mean value theorem. Therefore, it does not contradict.